Hello, it's Pietro Zucco here from ST Circuits, and today I'm going to show you how to get started with a very cool device. It's a Raspberry Pi Pico. What's the difference between a traditional Raspberry Pi and the Raspberry Pi Pico? The Raspberry Pi is a full computer. It has HDMI connector, USB, audio, video, Ethernet, and so forth. You can install a traditional operating system like Linux. It's also more expensive. The lowest spec of a Raspberry Pi 4 with 2 GB of RAM at the moment of recording this video is about £50 in the UK and $45 in the US. The Raspberry Pi Pico, on the other hand, is the first microcontroller released by Raspberry Pi. It's cheap, starting at $4 US, and as a microcontroller, it's more similar to an Arduino board. You have a lot more control over the hardware. It's also easier to access to all its capabilities. It's fast and it's so tiny that it's perfect for any kind of projects. In terms of specs, it has a 133 MHz clock speed, which is not bad at all, 264 kilobytes of RAM, which is plenty for the kind of projects you can do with it. It has 2 megabytes of flash memory, which is really a lot for all the code and data. And if you buy the Wi-Fi model, it has a 2.4 gigahertz Wi-Fi. You can program it in MicroPython, C, C++, and Rust. In this video, we will use MicroPython. If you never used Python before, I have a playlist with a quick crash course to learn how to code in Python for absolute beginners. The links are below in the description. The process to get it running is very similar to all operating systems. I will do it in a Mac here, but you can perfectly follow the same process on Windows and Linux. If you get stuck, leave a comment below and I will be happy to help. There are three kinds of Raspberry Pi Pico. One of them comes with the head pins already soldered that you can use on a breadboard. The other one doesn't have the head pins, you can put them yourself. And finally, the one that has the Wi-Fi. The next step is to download MicroPython. Go to the Raspberry Pi homepage and click on hardware. From there, search for the Raspberry Pi Pico series and click on more info. Then click on get started. Scroll down until you find the MicroPython. The instructions here are very good, you just can follow them. But here, what you need to do is to download the MicroPython for the model of the Raspberry Pi Pico you have, either the normal or the Wi-Fi one. In this case, I'm going to do it for the normal one. Just click on that and it will download in your computer. The next step is to connect the Raspberry Pi to your computer. Do you see this button here? It's called boot cell. Now, while you keep the boot cell button pressed, at the same time you connect the USB cable in the Raspberry Pi Pico, which also should be connected to your computer. You should see in your computer something that looks exactly the same as if you plugged a USB drive. Drag and drop the file that you just downloaded and the Raspberry Pi Pico will disconnect. Now, the software we can use to access our Raspberry Pi Pico is Sony. This is an open source Python IDE, which is very easy to use. I have a full course about how to use Sony and how to get started in Python, links below. When you start Sony, you can see here on the bottom that says Python 3.7, whenever. This is basically the interpreter that is installed with Sony. Once you have your Raspberry Pi Pico connected to your computer, you can click here on the bottom and then you can see that it says MicroPython Raspberry Pi Pico. Once you click on that, you will see that something changes. Here on the bottom in the interpreter, you see that now it says MicroPython version whenever it's here. Basically, you're connected here with a Raspberry Pi Pico. So for example, if I now type a command, print hello world, and it prints us here, it's actually not happening in your computer. This is a Raspberry Pi Pico which is interpreting this command, is running MicroPython inside of it, and is executing this line of code. So this line of code was executed by your Raspberry Pi Pico. Now let's do something really exciting. For example, blinking an LED. The Raspberry Pi Pico already has an LED in its board, so we can use it to test our code here. In the upper part, we can type and save the file in the Raspberry Pi Pico. So first of all, we need from machine import pin. These are libraries which are already included in the Raspberry Pi Pico, which you can make use to control different parts of its hardware. These libraries are included in MicroPython that you just installed. From time, import sleep. Then we declare a variable LED equal to pin 25, which is the pin corresponding to the LED, pin out. Then while true, this is an infinite loop, LED.toggle. Toggle is a function that is going to revert whenever state the LED is. In this case, when we turn it on, the LED is going to be off, so it's going to toggle it into on. Then we sleep for half a second before we run this program. Let's save it. We can go to the floppy disk icon here, or we can go to File and then Save. Sony is going to ask us if we want to save this file in this computer or the Raspberry Pi Pico. We have to select Raspberry Pi Pico. We give a name of main.py, okay, and now we can see here that Raspberry Pi Pico and this file is main.py, indicating that this file exists on the Raspberry Pi Pico. So now when we run this, we can see that our Raspberry Pi Pico LED is blinking. To stop it, we can just click here and stop, and it should stop the program. Now let's try something a little bit more interesting. Let's play a random sequence of sounds using a buzzer. First, we need to import some libraries. So from machine, import ping and PWM. PWM stands for pulse width modulation. This is often used to control motors like servo motors, lights, and many other electronic devices. Basically, digital outputs can only be on or off. If we connect a motor, it would only operate at full power when turned on or being totally dead when turned off. This is not very useful, so if we want to operate it at a certain speed in between, we need to simulate varying levels in the signal. In order to do that, we need a series of pulses at a certain frequency. Thanks to the library that we are importing here, we don't have to deal with the low-level technicality related to this, as we are going to see just in a minute. Then we import sleep. We also import random, because we want to generate random frequencies. Then we declare a variable called buzzer, which we set to the pin 11 and is going to work as a PWM. In this particular instance, the pin is 11 because I have a buzzer that has the cables with the perfect distance to match that particular pin. You can use any other pin that supports PWM. Then we set another variable called freeq, which is going to be the frequency, and here we set an initial value. We want to play this into a for loop. We don't want this to run endlessly, so here the range is from 0 to 50. We set the buzzer frequency to the initial frequency first, the buzzer duty, we give it a little bit of time to play the frequency, set the duty to 0, and finally random is going to return a number between 20 and 500. Then let's click here and run our masterpiece. Finally, once you have your program in your Raspberry Pi Pico, you don't need a computer every time you want to run it. You just plug the USB cable on it and it will start executing it. As you can see here, it's playing the sound, then I unplug it, stops, then plug it again and starts over. This wraps it up for now. I hope you have fun and learned something new. Now you're ready to start coding for the Raspberry Pi Pico. In later videos, I will show you some more practical applications in different projects. So remember to subscribe, and as always, thanks for watching and see you in the next video.